So continuing 4.1 in trig, this is 4.1b as in boy, the second video. And we had talked about in the last video about the sine, and I had a table here to give you an idea, or a picture to show you what the sine looked like. It starts at the origin, goes up to 1, down to -1, and up to 2 pi. So this is in its standard form. This is in the form of y equals the sine of x, or you could write it instead of y, f of x equals the sine of x. So that's the graph of that particular one. So remember, when we were solving, when we were finding the y value, we would plug in one of the radian measures here, like pi over 2, and when we put pi over 2 in there and we took the sine of that, again in the radians of your calculator, it would give you a y value, in this case of 1. If we put the sine of pi in there, it would give us a y value of 0, and then we could go and draw this smooth little curve here. And then we talked about up to 2 pi being one period, the distance it goes until it starts repeating itself. And then I had mentioned that the height of this and the bottom of this, the distance, that's called your amplitude. And your amplitude goes from your middle section right here up to the highest point, or from here to the lowest point. So the amplitude of this is 1. It goes up 1 before it starts down again. And one of the ways the book expresses how to find this is they take the highest point and the lowest point. So the distance between the highest point to the lowest point is 2, and then they divide it by 2, and they get this distance from here to here. I really don't do that. I usually look at where the center line goes through and just see how high it goes or how low it goes, and that's the distance is 1. So that's called the amplitude. If this particular drawing went up here to 2 and then back down here to 2 and up, the amplitude of that yellow one would be 2. Alright, so that's the sine wave. Now let's look at the cosine wave. And this formula for the cosine wave is very similar to the sine wave, except it's y equals the cosine of x, or f of x equals the cosine of x. So again, in order to find the points along this x-axis, or you put in the cosine of pi over 2, and when I put in the cosine of pi over 2, when I did it over here, I got 1. When I put it in over here, I get 0. So that's why the point is there. If I put in the cosine of pi, I get -1. Whereas over here, when I put the cosine of pi in, I got 0. Or I put the sine of pi in, I got 0. So notice the difference. The graph is the exact same. The period is the exact same to where it starts repeating itself. So if I start here at 0 and I go over to where it starts repeating itself, it again is at 2 pi. But this whole thing is shifted over this far. It's shifted over to the left, pi over 2. So notice here is where it starts at 0, and here is where it starts. So the cosine is just like the sine, it's just shifted over. Pi over 2 is the only difference there. So in fact, let's erase this part here and just have that. So this would be the cosine, the yellow, and the blue is the sine. So the only difference is just a little bit of a shift there. The amplitude is the same. The length of the period is the same. We just have a little bit of a shift there in the cosine. Alright, so that is the cosine and the sine. So let's talk about the period of a sine, and we had mentioned that a little bit earlier. So the period of a sine is 2 pi. That's where it starts repeating itself. Alright, let's look at the period of a cosine. It is also 2 pi. Now another thing that's always good to look at is where, when I'm drawing this, because I want to be able to draw this pretty fast and easy, and how I draw this, if I know where the sine line crosses the x-axis, then I've got some points real quick. Alright, so let's look and see where that point crosses the x-axis, or where that line crosses the x-axis. Let me get a darker color here. Alright, the x-intercepts, where it crosses the x-axis, are always at n times pi. N is an integer, and remember, an integer are all the positive and negative counting numbers, not the fractions, not the decimals, just the counting numbers. So the x-intercepts are always going to be some number times pi. So for example, if we want to know where this crosses, if I put a 0 in for n, it's going to cross the x-axis. It's 0 times pi, which is 0. If I were to put in a 1 pi there, it crosses the x-axis at pi, right there. If I were to put in 2 pi, it would cross the x-axis at 2 pi. Okay, so this will always work. N times pi is the x-intercept. Put that in your notes. X-intercept for sine is n times pi, any number where n is an integer, not a decimal or anything else. Alright, so let's look at cosine and see what that does, and we'll continue on with the green ink here. The x-intercept for cosine is two n plus 1 times pi over 2. So again, we can put any integer we want in for this n value, multiply it by 2, add 1 to it, multiply it by pi over 2, and we will get these points here where it crosses the x-intercept. So let's try one. Let's put in the number 1 here. So let's put in 1 for n. 2 times 1 is 2, plus 1 is 3. 3 pi over 2, this will cross. And sure enough, at 3 pi over 2, it crosses. If I put in 0, 0 times 2 is 0, plus 1 is 1, it's going to cross at pi over 2. Sure does. If I put in negative 1, negative 1 times 2 is negative 2, plus 1 is negative 1, so it's going to cross at negative 1 times pi over 2, which is negative pi over 2. Sure enough, it does. So this formula works to find the x-intercept where it crosses the x-line for the cosine. So make sure you've got that down. That's important for you to have because you're going to want to use that. So that's it for 4.1b.